Hello everybody, this is Itsu. I was also looking at this diagram from user Verpis about this coil shorting, and I was trying to find a way to use a MOSFET for this S2 switch, and working together with Verpis I came up to this final diagram, which was suggested by Verpis, and we have here a transformer 126, big transformer. It's designed normally for 220 volt in and 1400 volts out, 1.4 kilovolt out, but I use it to drive it with a function generator at the moment, and I'm driving it with a sine wave 50 Hertz at the moment, 50 volts peak to peak. And the secondary is connected this way. We have a 1N4007 diode going to a IRF 740 MOSFET drain source. And here we also have an 1N4007 diode. I changed it later on to a different one, but it doesn't make any difference. And we have here a 600 nanofarad cap and a voltmeter across it. And I have a second function generator, and I am hand syncing both to match the 50 Hertz. This one has a 5 volt positive DC, 5% duty cycle, driving the gate of this MOSFET, trying to shorten out at the top of the sine wave. So that's the idea. I put it on a little breadboard, and this is the 600 nanofarad cap. I have the IRF 740, I have here 4007 diode. This is a Schottky, fast Schottky diode for the second one, but it doesn't make any difference. And this is the transformer I'm using, and I'm measuring at the moment the gate signal, and across the drain and source being here between the drain and the source. Sorry, not the drain, but at the junction of the both diodes. And these are the signals. We can see at the red probe is the signal at the junction of the diodes, and the gate signal is the yellow probe. And each time it's synced, it's now slightly off sync. I will adjust it in a moment. I have this little function generator put at 5% duty cycle, 51 Hertz, and this one is in driving the transformer primary. So the red probe we had at the moment hooked up is showing we have 96 volts, because I have this set at halfway, which is 15 volts, like mentioned on the diagram. And each time we sync, the gate signal is in sync with the top, we can see that it shortens the upper half of the I will try to manually sync now the gate signal, so that it stops on the almost there. So we're now exactly in sync with the both function generators. It will shift. Of course I have to make a real sync here somehow, but this is just the first steps. So of the 96 peak to peak volts, we have now a, oh, it goes off, a spike which drives up the peak-to-peak voltage to 154 volt. And you can see the voltmeter, which is across the cap. It is raised till 106 volt DC. When I let it go, it goes back to half of it. So we have 64, 70, 47 volts on the cap DC. Now I have to go back again, let it go on top of the peak. You can see the voltage is rising again, but this is all due to this peak we are having. I can adjust the duty cycle, but it doesn't make any real difference. The optimum is 5%. So this is with this little circuit it's possible, and only one MOSFET, to make a coil shortening and to have some extra voltage in the cap, but if it's really usable, I doubt it. It's only 600 nanofarad. I will try to make a resonance now for this transformer. It resonates at 30 kilohertz, and then I will try to sync again the both function generators to see what kind of signal we have there then. Okay, thank you for watching.